All right, so the last little stretch here. How do you prepare an amide? Meaning, how do you synthesize? How do you make an amide? Well, it depends on which amide you want. Do you want a primary amide, or you want a secondary amide, or do you want a tertiary amide? In order to prepare any amide, you're going to need heat, usually about 100 degrees Celsius, and a catalyst. If you want to make a primary amide, you have to start off with ammonia and a carboxylic acid. So let's say you have ammonia here, and you have a carboxylic acid, any carboxylic acid. Let's just go ahead and do ethanoic acid, or we could call it acetic acid, either way. So think of it as a dehydration. You're going to be removing an HOH, remove a molecule of water. So your nitrogen is going to lose one of the hydrogens. It's going to go off with the OH as water, and then you end up with a primary amide. So you've just created acetamide or ethanamide. If you want to make a secondary amide, you start off with a primary amine. You don't start off with ammonia, you start off with a primary amine. So let's say I've got this primary amine here. So it's methanamine, okay, or methylamine. And you're going to have this, you can have a different carboxylic acid or the same one. Again, we're going to remove a molecule of water. You remove one of the H's, and the OH goes off as water, and you end up with this secondary amine. Secondary amide. I apologize. All right, can you see it? See, I know it looks a little crowded here, but this is your secondary amide. You have, it's an N-methyl ethanamide or N-methyl acetamide. And then finally, to create a tertiary amide, you need to start off with a secondary amine and react it with a carboxylic acid, remove an HOH. So I'm going to just tilt this here for a bit so you can see this. So I've got a secondary amine here. And then let's just do the same carboxylic acid. All right. And I'm going to remove an HOH. So this OH and this H, just to make my life a little easier, I'm just going to go ahead and remove them. Scoot this over a little bit. So I removed a molecule of water, and voila, there you go. You've got a tertiary amide. So primary amides, ammonia and carboxylic acid will make a primary amide. Secondary amides, primary amine and a carboxylic acid. Tertiary amides, you need a secondary amine and a carboxylic acid. In each case, you need a high temperature, a catalyst, and you're removing a molecule of water. Okay, so that's it for preparation of amides. Before I get to the last topic, which is hydrolysis of amides, let me mention, and I can't remember honestly if I talked about this in a previous video, but I just wanted to make sure you knew what aniline is. Remember benzene ring? This is benzene. If you put a methyl group here, it's toluene. If you put an OH here, it's phenol. But if you put an amine here, it's called aniline. So it's not called aminobenzene, it's just called aniline. The other thing, I can't remember if I mentioned in earlier videos, but I just better mention it now just in case. If you have an amine group in a molecule with other functional groups, so let's say I have this. Amines have very, very low priority. So they have lower priority than alcohols, aldehydes, ketones, carboxylic acids, all of them. So what are we going to name it? Remember how when an alcohol was in a molecule with a carboxylic acid or with an aldehyde, it's called a hydroxy group? Well, this is called an amino group. So the only time an amine is part of the parent name is if that's the only functional group there, okay? But other than that, you're going to call it an amino group. So you can recognize that this is an aldehyde. So this is carbon 1, obviously. 1, 2, 3, 4, 5, 6, 7, 8. So this would be an octanol, and then this would be 6-amino octanol. All right, I guess I have to deal with the phone in a little bit. All right, 6-amino octanol. It looks weird having the 2 O's. I guess you could drop one of them, but you get the idea. All right, so the last thing we're going to do is talk about the hydrolysis of amides. Hydrolysis of amides. I think I need to get a new black marker here. All right, so there are three ways you can hydrolyze an amide. You just break the amide bond with just water and heat and an acid catalyst. Or you can react it with an actual strong acid, or you can react it with a base. So let's do the first one. This is just hydrolysis with just plain old water. So we've got our amide. Just make it really simple. And I'm going to throw in some water. I'll put in some heat, a little bit of a catalyst. And what are you going to end up getting? Well, you are, if you break the bond, think of water, remember, as HOH. You're going to end up with a carboxylic acid. So carboxylic acid. And whatever this is. So if you just put an H here, you'll end up with ammonia. If this was already, if it was a secondary amide, you'd end up with a primary amine. So for our purposes here, since I have it as a primary amide, then you just have ammonia. Okay? Now, if you're going to hydrolyze it with an HCl, let's say I have a hydrochloric acid here. Okay, so let's go back to my amide again. And I'm going to put HCl. And I also have some water, so I need water in this too. So it's HCl aqueous. Okay, so what you're going to have for this one is that you'll end up, you have to use this chloride ion. You're going to use this, so playing around with it a little bit, you end up with a carboxylic acid. So this is a carboxylic acid. But now we've got this ammonium, because we're trying to make use of all the hydrogens. So we're going to have an ammonium ion and a chloride ion. Now, if there was a methyl group here, then one of these would be a methyl group, and this would end up being an amine salt. So what you should know is that just regular hydrolysis of an amide with HCl will give you a carboxylic acid and either a salt, ammonium chloride or whatever, or an amine salt. So this would be methyl ammonium chloride. Okay, that's with HCl. And then the last one is with sodium hydroxide. So let's say I've got an amide, but now I want to hydrolyze it with sodium hydroxide. Remember when we had our esters and we created salts, carboxylate salts. So what we're going to do now is create a carboxylate salt again with the carboxylic acid group. So our amide again. Let me go ahead and change it up and turn it into a secondary amide. And I've got my sodium hydroxide. It's aqueous. There's always water involved. So I'm going to turn this. This over here is going to turn into a carboxylate salt. So this is what this one's going to look like. Okay, so this is a carboxylate salt. Remember in our saponification reaction back in the esterification, sorry, not esterification, with the esters. So an ester with the sodium hydroxide gives you a carboxylate salt. So an amide with the sodium hydroxide will also give you a carboxylate salt. And then what do we have left over? Just a plain old amine. Okay? And that, I think, I'm looking at our what you need to know list. I think that does it for us, guys. We are all set. Okay.